Hi guys, this is Dr. Foy, and here is the review PowerPoint for Exam 4. Okay, so I want to add to this that there are a few slides missing because those questions actually are about the topics that we're going to cover next. So when you see a few of these slides are not here, just assume that that was not information that was covered for this exam. There were about Lewis structures, Lewis dot, expanded octets, things like that, that again we will cover in the next section, but we didn't cover it this time. All right, so this is the review. Okay, here are the first couple questions, and the first one, longest wavelength. You got to think through this a little bit, and when you think about the electromagnetic spectrum, the gamma radiation on the left side, as we've looked at it, is the shortest wavelength, right, and the highest energy. This one wants the longest wavelength, so you look through these. Radio is the longest wavelength, but microwave is right beside it, so microwave is the right answer. Again, the next one, the arrangement, lowest energy to highest energy. Well, the radio waves are pretty low energy, but then it goes straight to X-rays in A. B goes infrared, visible, UV, and then X-ray, and that's actually going lowest to highest, so that's the correct answer. But then you look at C, and it goes X-ray to gamma, and then goes all the way back to infrared, and that doesn't make sense. And finally, D, microwave, ultraviolet, but then it bounces back to infrared, and that doesn't make sense, and divisible. Okay? Okay, so when I calculated this using C equals lambda nu, I came up with this answer. Recognizing that this didn't translate that well, this is 5.6 times 10 to the 14th hertz. Okay, so when n equals 4, we know that the possible values for L are 0 to n minus 1. A is 0, 1, 2, and 3. And then the second question here, a particular orbital has n equals 2 and L equals 1. That defines it as the 2p, and so both of those answers are A. Okay, so here I've crossed out in the boxes the not a proper set of quantum numbers. So n can equal 3, that's not a problem. When n equals 3, L can equal 2. But when L equals 2, m sub L can only equal minus 2, minus 1, 0, and plus 1, plus 2, so that's wrong. The next box, n can equal 2 in the first one there, but L cannot equal 1. It can only equal 0. I'm sorry, it can't equal 2. It can only equal 0 and 1. Okay, so that first line is incorrect. Okay, so the first thing I did was I wrote out this electron configuration, right? And then I started to examine these, and I know that this one doesn't work because it goes directly to L equals 1 and then to L equals 2, and I only need an S and a P, and I know this one doesn't work. And then I started to look through this one, and as soon as I got down here, I recognized that this m sub L is not allowed, right? Because when L equals 1, it's got to be minus 1, 0, and a plus 1. And so I go over to this box, the last box here, and this one is the first S, this one's the second S, this one's the first P because it goes into the minus 1 over here, and then this is the second P because it goes into the 0, right? So it looks something like that. So they've defined this as the 3D, right, subshell. And so we know that, first of all, n equals 3, so we have all those choices. But then we also know that D, L equals 2, right? So we have this choice and we have this choice. And then we also know that m sub L describes the number of orbitals, so minus 2, minus 1, 0, 1, and 2 leads us to 5. So this is the correct answer, 3, 2, 5. So looking on the periodic table, I find cesium, Cs, to be in the 6th energy level, and so we know that it's going to occupy this 6s. Then I look for the element with the ground state electron configuration of a 3s2 3p3, which now means that we're in the p block. 3p3 goes to phosphorus, and so it's P, right? And then the element with the highest potential energy electron configuration of 4s2, again, I look at the second or the alkaline earth metals, and I start scrolling down through there, and there's calcium, right? And so this has a 4s2 configuration. Okay, so I'm looking at this, and it says they have the same electron configuration. That means they have the argon core, right? Chlorine has gained an electron, sulfur has gained 2 electrons, potassium has lost 1, calcium has lost 2. Calcium has the most protons and it's lost 2 electrons. Therefore, this is going to be the smallest, right? Remember that cations get smaller, and the more protons it has versus electrons, the smaller it gets. The opposite in this next question with neon, which one is the largest? Well, oxygen at a 2 minus is going to take on 2 electrons and again be the largest. And then which is represented by the electron distribution that was given there. It's a 3d10 4p4, so now we're into the 4p, and count 4 over and you get to selenium. So that one's selenium. And then 4s1 3d10 is one of the exceptions that we worked with before, and that one is copper. Okay, so let's work through these three. Which element would have the highest first ionization energy? So I know that it's not sodium because lithium is higher because it's in the same column. But then I look at lithium and fluorine and chlorine. Well, fluorine is in the same period, and so I know that it has a higher first ionization energy. So lithium is out. And then I look at fluorine and chlorine, and fluorine is actually above chlorine, so it has the highest. Arranging carbon, nitrogen, oxygen in order of increasing first ionization energies. And so which one has the highest, carbon, oxygen, or nitrogen? And one of the things that we saw was that blip. You remember the blip, right? So when we went from nitrogen to oxygen, oxygen actually had a lower ionization energy. So now look for one where nitrogen is lower than oxygen. And then we also have to have nitrogen lower than oxygen with carbon higher than nitrogen, right? So it's this B. And then which has a positive electron affinity? In other words, it really doesn't want the electron, right? It doesn't want the electron. Fluorine has a very good large negative. Chlorine has a very large negative. Lithium, it's okay, right, with getting one because it completes its S. But nitrogen really doesn't want an electron because it has to pair it up with another electron in one of the p orbitals. And so this one's B. Okay, so in this first question it says these are all isoelectronic. I didn't use that term in class, but isoelectronic simply means they have the same electron configuration. So that means that the fluoride ion, right, has the same electron configuration as sodium, as oxygen, right? The electron configuration we're talking about is that of neon. So which one's going to be the biggest? Well, oxygen's going to be biggest, followed by fluorine, and then sodium is going to be the smallest because it's the positive. Okay. So this says decreasing size, so from largest to smallest. That means we got to start with O2 minus, then we go to F minus, and then we go to sodium. So this one's D. You don't need to worry about this question, but if you're interested, lattice energy is um, the binding energy between ionic species, and the smaller the ion and the larger the charge, the higher the binding. Okay, so it's just asking which one of these, magnesium, calcium, strontium, or barium, is the smallest, right? And that's actually listed in the way that they appear on the periodic table, and it goes from the smallest up to the largest. And so magnesium oxide would have the most negative lattice energy. But again, you don't need to know that for the exam. Okay, so this one, all three of these questions are just about counting valence electrons. So when it says outer shell, that's what it's talking about. And so if we look at phosphorus atom, phosphorus is in the third energy level. It's a 3s2, 3p3, and so it has a total of 5 in the outer shell. And then valence for pF5, right? So we know that um, P has 5, and then we look at F, and F actually has 7, but there are 5 of those. So 5 times 7 is 35, so it has a total of 40 valence electrons. This is actually going to help us when we start talking about Lewis dot structures. But this SO4 2 minus, right? We can look at that and say, what about sulfur? Well, sulfur has, let's see, sulfur and oxygen both have 1, 2, 3, 4, 5, 6. And so sulfur has 6, oxygen has 6. That's 5 times 6, right? Because you got 4 oxygens and 1 sulfur. So that's 30. But you got a minus 2 charge here. So you got to add 2. So that comes out to 32. And again, it's that answer. We didn't do Lewis structures, okay? So don't worry about Lewis structures. But you can count valence electrons. You know how to do that. Okay, so in this top one, it didn't come through. But this is a 4s1 3d5, okay? And which transition metal? Well, it's the exception, right? It's chromium because it promotes that 1 electron up into the Ds. So you get these 5 Ds all half filled. How many electrons the outer shell of bromine? Well, bromine is one of the halogens. The outer shell is 4s2, 4p, 4s2, 4p, 1, 2, 3, 4, 5. Okay, so it's 4s2, 4p5. That means it's got 7 valence electrons, outer shell electrons. And then what would you expect the noble gas to look like? Well, S2P6, right? Completely filled.